Hi everybody, Physics Ninja here. Today what I want to do is I want to show you a physics brain buster. This is a nice little physics problem I recently came across and I thought I'd make a video to share it with you. So here's what we're going to do. Alright, so we're going to take a tennis ball like this one, suspended to a hook with some fishing line. We're also going to take one of these, a helium-filled balloon. We're going to go out to the car and do an experiment, and the goal is for you to describe the physics that you're going to see. I'll provide you with some empirical evidence, and then you tell me what's going on in this problem. So here I got a helium-filled balloon. We'll use that one in just a minute. And I've also got another thing. I've got a tennis ball here that I've just attached a hook. What I'm going to do is I'm going to suspend both of these in the car, and I'll show you the setup in just a minute. All right, so what we're going to do here is I've got the tennis ball kind of suspended, and it's connected to this fishing line, and I've got it kind of anchored over here at the top of the sunroof. What I'm going to do now is I'm going to accelerate, and I want you to describe what the initial motion of the tennis ball is going to do. All right, so let's give it a try. All right, you got your answer? You got it locked in? All right, what do you think is going to happen to this tennis ball as I kind of stomp on the gas? Now, this is a forward escape, so the acceleration is pretty small, but we're going to give it a good go. All right, it's safe. There's nobody around me. I've got it in drive. Got to be careful. There's a car right behind me. It's our own minivan, so I don't want to hit that one. All right, we're ready to go. In 1, 2, 3. I'm going to start off slow, and then I'm just going to hammer it. Here we go. Whoa, good job. Okay, I'll start moving slowly, and then I'm going to really press on the accelerator. All right, 3, 2, 1. Watch what happens to this tennis ball. Whoa! In this next case here, what we're going to do is we're going to decelerate. So I'm going to approach a stop sign over here. As I approach the stop sign in about 3 seconds, 2, 1, I'm going to apply the brakes really hard. All right, here we go. 1, 2, 3. Whoa, you see it go forward in that case. Experiment number 2, I've got a helium-filled balloon here, a nice heart-shaped balloon, because I love physics so much. And this is what we're going to do. We're going to repeat the same experiment. So here I've got it now. Since it's helium, so it really wants to go up. The car is completely sealed. I've rolled up all the windows. I've closed the sunroof. And here's what we're going to do. I've got a little piece of tape here holding it down. So if I just let it go, there it is. It's just being kind of... it's in equilibrium basically, right? Moving a little bit, but we're not moving side to side. So what we're going to do here is we're going to repeat the same experiment. What do you think is going to happen to the balloon when I accelerate forward to begin with? And then later on, I'm going to go back to that same road and I'm going to apply the brakes to slow down, and we're going to see what's going to happen. So what's your guess? What do you think is going to happen to the balloon? All right, so let me put it in drive. I'm in drive. All right, let's just start going a little bit. All right, are we ready? All right, here we go. I'm going to stomp on it. You might hear the motor. Here we go. 3, 2, 1. Whoa, you see that? In 3, 2, 1. Whoa, you see that? Look at that balloon. It's moving forward as I accelerate. Okay, we're now traveling at about 15 miles per hour. We're going to approach the stop sign again, and I'm going to decelerate here in about 3 seconds. Again, traveling at 15 miles an hour, and we're going to hit the brakes here, so we're going to decelerate. 1, 2, 3. Look what happens. Oh, moves back. Hey, how you doing over there? Let's try to accelerate. Oh, hit the brakes. Oh, I'm moving in the opposite direction of this balloon. Let's see what happens now when I decelerate with the balloon. In 3, 2, 1, hit the brakes hard. Whoa, hey, how you doing? Let's. All right, we're going to accelerate now in 3 seconds. 3, 2, 1, go. Yeehaw! Let's see them both in the same shot. Never been done before. Let's give it a go. Safe, no kids in the neighborhood. All right, are we ready? So again, we're first going to accelerate forward. So let's see what happens in this case. Make sure there's no one around me. In 3, 2, 1. Oh, good job. All right, one more little turn. Okay, I'm approaching the stop sign. I'm traveling at about 15 miles per hour, and I'm going to quickly step on the brake here. All right, 3, 2, 1, here we go. Wow, kind of interesting. Let's try to accelerate again in 3, 2, 1. Kind of interesting, isn't it? Do a right turn here, sharp right turn. Oh, man, look at that. Tennis ball is coming toward me. That balloon is actually moving away from me. Kind of an interesting phenomena. What happens when I veer to the right or if I turn to the left? What do you think is going to happen to the tennis ball, and what do you think is going to happen to our heart-shaped balloon here? All right, here we go. We're going to turn to the right. Hopefully you're able to see that on the video. And we're going to do another right turn. Let me stop the tennis ball over here. We're going to do another right turn in just a second here. It'll be a sharp 90-degree turn. Let's have a look at what happens in this case. Slowing down a little bit. And now we're turning to the right. Here we go. Whoa. What do you think happened in that case? Does that make sense to you? What is the underlying physics behind this phenomena? All right, it's now your turn to use your physics knowledge to come up with an explanation of this simple experiment. So, a couple questions. Why does the tennis ball behave differently from the helium-filled balloon, right? When I accelerate, when I speed up, or when I slow down, right? We saw completely different behavior between the two objects. Number two, why did I see a difference when I was turning to the right, right? In those videos, when I turned to the right, the balloon and the tennis ball were going in opposite directions. How is that possible? It's actually a pretty simple explanation, but I want to see what you guys come up with. So please think about this problem for a little bit. You can either leave your answers in the comment section below, or feel free to email me at onlinephysicsninja@gmail.com. I'd love to see your solutions, and maybe in a couple weeks I'll make a video solution of what I think is going on in this problem. I hope that your solution will involve some of the forces acting in this problem. Some of the forces include tension, the weight of the object, maybe the buoyancy, especially acting on the helium-filled balloon. That'll be an important force. For the more advanced students, your explanation might involve terms like non-inertial reference frames. All of those things should be included in your solution. All right, I'm looking forward to see what you come up with, and thanks for watching.